Okay, great. Yes, thank you so much. I'm really excited to be here today. I'm going to talk about what we did in Civil 372, which is a third year civil engineering class, is one of their core courses. For many of them, it is their first and last course in environmental engineering. But for other students, it is a foundational course in what can become a very long and fulfilling career path. And the course has a big lab component to it. And so this term we are challenged to think about, how do we do this remotely? My presentation is called From the Lab Bench to the Kitchen Table. And what we did was create at-home lab kits to explore core environmental engineering concepts for these third-year students. And I'd also like to acknowledge two teaching assistants we had, Sarah Roden and David Blair, who were essential to the development of this work. So the vision was that I wanted to give students a hands-on experience, create an authentic connection with the subject matter, foster deep and critical thinking about the core concepts in the course. And I wanted to do that by creating experiments that could be done safely at home. So safety was a key word for us this term. And the challenges were that we knew we'd have to get students to build their own lab equipment to do analysis. And the constraints were we needed everything to come from the grocery store. So we wanted it to be safe and non-toxic, or from the recycling bin, so readily available. So the concepts I really boiled down, like what do they really need to get the experience with this in the course? And the first one was water quality analysis. And that's where developing instruments was going to be a big issue. So how can you measure something when all you've got at home is maybe a ruler and things you'd find in your kitchen? The next concept was water treatment, and that's really about connecting a lot of the theory we cover in course with practical hands-on learning. We covered reaction kinetics, which is about how quickly chemical reactions proceed, and there's no way to know this just by looking at a chemical formula. You actually need to determine it experimentally. So we derived all the equations in class, and we needed to look at it in reality. And the last concept was mass balance and reactor design. And this is a foundational concept for any type of process thinking. And lots of environmental engineering applications rely on having good, solid understanding of mass balance in reactors. And you can think of a reactor as something like a lake or a river, or at a water treatment plant. Those are all based on understanding mass balance and reactor design. So we actually started in November, December 2020. I got some extra funding. Thank you so much, Queens, to hire a TA to develop some of the core concepts and think about, how do we just do this logistically? So David worked in the lab and he did some experiments at his kitchen table to come up with how do we build these instruments. In January, I had a TA for the course, Sarah. She was refining all the concepts that David had developed, testing them out in her lab. We had Stan in civil engineering, making sure that we followed all safety protocols. So we checked with health and safety, because some of the things we needed students to get weren't available at the grocery store, and we needed to mail them aluminum sulfate, which is a white powder. And so we were a little bit worried about sending that in the mail. And also, technically it's a food item, but you still don't need to eat it. So we need to make sure we got the right labels on it. And so we had to do a lot of checking and procuring of items, and things are not easy to get during a pandemic. In February, it was about kit assembly. So we got mailing addresses from all the students, and Stan actually went out and did porch drops, so safe porch drops in Kingston with Kingston students, which I think was actually more valuable than I thought it was at the time, in terms of creating a connection with someone at Queen's stopping by and dropping something off for you. And we also had to get students buy some of their own reagents. I had to stop calling them groceries. So one of the things was red cabbage. And so I had a lot of comments about the price of red cabbage and couldn't we share red cabbages? So we had some discussions about safety. And we had to get them their kits, which had some items from different departments on campus. So they got a little magnet and a Queen's pen, as well as the reagents. And then we mailed 96 packages, or porch drop 96 packages all over Kingston, Canada, and the world. And in March, it was lab month. So we took the entire month and just focused on the labs. So in this lab, I would call it deep thinking. So normally measuring pH would be something that is just one of many assessments that you do. I wouldn't spend much more time on it because you've talked about pH in school, whether something's acidic or basic. So it's not a concept I would spend a lot of time on. And it's just in a lab, it'd typically just be, you put the probe in, you press a button, it gives you a number, you write it down, and you don't think about it much beyond the measurement itself. But in this lab, they actually had to build their own tool. So with the red cabbage, they extracted an organic molecule, anthocyanin, which is a color indicator. So they created different solutions. So you have the photos with the different blue water, which is the anthocyanin. They changed the pH by adding, lemon juice or baking soda, etc. And they compared it with the known methods. So using a litmus test, if you have a pool, you've probably seen these before. And we also got them to turn their cell phone cameras into a very basic spectrophotometer using visible light. So they took photos of it, we gave them instructions for all different types of paint programs, and then they picked the red value, so they were able to get a standard metric to compare different types of treatment. So in this lab, they got to some deep thinking about what are we really measuring? What is happening with these color changes? So we asked them, why do pH indicators change colors? And we asked them about the specific ones in this experiment. So they had to go back to organic chemistry and explain that using protonation and deprotonation theory. So that was a synthesis between theory and practice. We got them to think of, how do you measure pH? Instead of what could be very cursory, instead of pressing the button and getting a result, we got them to deeply think about, what is measurement? And we also got to some critical thinking about what are limitations of some of the tools. So we talked about the example of citizen science. We asked them to find examples where citizen science, which is using, volunteers to go and collect information and share it with a central pool and trying to come up with an analysis. We got them to find examples of citizen science that had been used in water quality. And then we asked them to reflect on their lab experience about what are the shortcomings of collecting data. So they compared to their own experience of the differences between them and their lab group. We asked them about what happens when you have different sources of information from different people and using different instruments. So we got them to think about that value of calibration against a known standard. And then we asked them to think about ideas of how they could overcome limitations of citizen science data. And finally, we asked them for examples of, how is pH applied in engineering? So we asked them to come up with examples related to course material on drinking water treatment and wastewater treatment. And also, it was very useful for building onto the second lab on treatment, where we got them to look at, you have these pictures of dirty water on the right-hand side where they made up their own sort of muddy water. And then they used 3 different types of treatment to eliminate particles or settle out particles from their amended drinking water. So this is a typical treatment used in drinking water, wastewater. And pH is a factor there. So they got to use the same tools again. So with the at-home labs kit, it really gave them the hands-on experience that we wanted. It encouraged deep and critical thinking. I won't say this wasn't a logistical challenge. It really was, but ultimately it was worth it because it created authentic connections. And some of them I was really surprised at. And one of them was the connection between staff and students. And I didn't realize how meaningful that was, but I had a few emails from students asking me to pass on my thanks to Stan, the technician, for making sure they got everything they needed for the lab. And I do think it was the little extras that Stan went around campus procuring, like the pens and the magnets and the little buttons, to make students feel connected to Queens. And the other thing that happened was we had our at-home lab sessions were run during the tutorial. And so they had their TA there, and they were in breakout rooms where they could work with their lab group. So we tried to recreate that small group environment where they were alone together. So that's one of the things we were able to recreate. And some of them were able to take real advantage of that format and be very productive and really create a connection amongst themselves and with their teaching assistant. So with that, I'd like to say thank you, especially to David Blair and Sarah Roden, who were key developers in this process, everyone in civil engineering who helped with the kit assembly and logistics, the other TAs for the course, and the different offices and departments around Queens who contributed to the kit content. Thanks very much.